Welcome to the math path. Whoa, okay.
I did that on purpose.
Did you? It didn't look like it.
I
Okay, well,
extra big tip.
some things that we do on the math path are on purpose. And so this is one of them. So look at this. These two logs represent two numbers, okay? This log has a byte taken out of it. So this is kind of statically it's showing what happens without moving, okay? Or whatever. So if you have this log and then you take a byte out of it, see this byte? And you chop that off, and then you come over here, and what do you have left? You have a little bit smaller log right there. Okay? That's just a whole thing without a byte out of it. So this bridge over here represents the difference between them. So we can take and we could, you know, if the space between them was the difference, then you could count up how many were moved over there, and it should be the same. You know, this should be the same length as the byte, and you could set it up. You know, if we
And have your globs fall through.
Sometimes the math path is difficult. So 1, 2, 3, 4, just like those trains that Camilla was doing. It's the same thing. It all goes back to that, right? And you count them all, and eventually you're going to get over there, and then you know, okay, it's that much different. So,
What? How on earth did you know that?
well, because you count the difference between what's over here and what's over here. Or in our system, you don't have to count one by one. You just can see visually, and you know what it is. So, how does subtraction and addition fit into this? So subtraction, you'll notice, came first. It took me a while to convince myself that the great John Gabriel was right about this, but it is. That's the first thing. Addition does not come first. Subtraction comes first, conceptually and fundamentally. And what you're doing with subtraction is it is going this way, forward in time, based on how we explained the problem. Because you start with this and you take a byte out of it, and then you end up with this. So this, when you're going this direction, then it's minus. That's the minusing. You have your minus snake taking you that direction, right? The minus snake, you start with a number, let's say 8, and then you minus a number. Well, let's say it's something bigger than that, although it really doesn't matter which number is bigger or how big they are or whatever. Actually, it works for all of them, kids. But let's say this is 1, 2, 3, 4, 5, 6, 7. Okay, so your minus snake is eating up 7. You started with 8, and you're left with only 1 over here. Okay, and so that's that. Now, what if you, switched the arrow around so it's pointing the other way? What if it's pointing the other way? What if the thing that you want to know is the other way? So what if you know that you know about the 1? You already know that that's the 1 in the end, and you know that there were 7. That was the difference, or whatever. Then, what did you start with? It must have been 8. Or if you want to, usually we think of the problem the other way around, of putting the things together. So if you start with 1 and then put it together with 7, which is our little this, you shove them both together, and then you end up with your 8. So the byte is kind of, maybe this isn't the perfect, but the byte that you see, that's what's happening on this bridge, essentially, okay? The byte, you take out the byte and you count it, you figure out how much it is on this bridge. And you're counting on the number railroad track, because there is no number line, it's a railroad track, believe me. Okay, so that's all there is to it. So you can see This is addition, going from the whole number plus some difference that you want to add and to the new number that didn't originally have that difference in it, but now it does. And then if you want to go the other way with the minus, somebody could pretend there's a minus snake on it or bring me one, then you take the thing, and then you take a bite out of it, and then you count out how big is that bite, and then you figure out how you count out, well, what do we have left after the bite. That's all there is to it. They're the same things. One is backwards than the other, but the fundamental thing, the fundamental idea is difference, which that's just the difference. It doesn't really involve moving. It doesn't involve taking away or clumping together. Either one. It's just how much is the difference, and that's the root of both subtract or minus and plus or add. Thank you very much. Did you learn something?
No. Welcome to the math class. I do not understand the last video.
She didn't get it. So it may have been more hurtful than helpful. So here's what we're doing, okay? Let's say we had this number. We don't know what it is. Okay, it doesn't matter what it is. Then we want to see, look, it starts out as that, but then we're going to take a bite out of it, chomp, and we're going to take, and look, this is like an arrow. It's moving over there, okay? It's moving over there. Here, you want to move it? Okay. And where is it moving to? It's moving over to this other one, okay? So, yeah, actually, well, now I'm confusing myself a little bit. It all depends on how you present the problem, okay? But if you're, you know, if you're saying, okay, this number, and you minus that, then the thing that you want to know is this number. And so then you get that, because that went away. Now, let's say you're starting with that number and that number, and you want to put them together, then it goes that way. Then it goes that way, and you put them together. And that's the plus. So one is the minus and one is the plus.
Yeah,
So
now I understand.
do you really?
We understand, kind of. Kind of, we understand. Teensy bit. We still don't get it.
Okay, so that I haven't explained it well enough yet. Here's the problem setup. You start off with a bigger number, let's say 8, okay? And then this is the difference between them. See, it's in a glass tube. It's not moving. It's just stuck there. It's just a fact. You can't do anything with it. There's no motion involved. That's the difference between this and this. Difference between 8 and 5 is, let's say, 3, okay? So, oh yeah, it's plastic. You're right, but it's clear. Anyway, so let's say we're doing minus, okay? This arrow just represents the direction we usually read the problem, left to right, left to right. And so how we say it is, we say 8 minus 3. So we take this smaller number, the 3, and we take it away, and the minus sneak eats it, okay? And it goes away. I said it wrong before. It does not go over there. It goes away. It disappears, and then we're ending up with 5, okay? Let's switch. And then now let's say we're doing addition. Out from under the log, out of the earth comes the 3, okay, the smaller number, whatever. And then it goes along. So we start off with 5 plus 3, and we make it become 8. 5 plus 3 is 8. 8 minus 3 is 5. They both have to do with the difference between them being 5. That's how it all fits together. Do we get it now?
Yeah!